Hello, I hope you are doing well. Now we will start a new soil classification system. Now we will start the WRB. WRB is the acronyms that we use for World Reference Base for Soil Resources. The WRB is a soil classification system created by the United Nations, the FAO. And this specific system is a kind of international soil classification system that can be used by any country, and it is created and feeded and reconstructed and changed using the experience of researchers for soil researchers from everywhere. So anyone in the world can send proposals and anywhere can be used to classify soils according to WRB. The WRB has one specific basic concept that is the definition of soil. Okay? The WRB wants to classify any kind of material in the first 2 meters below the soil, the Earth's surface that is in contact with the atmosphere, excluding living organisms, areas with continuous ice cover, or any other kind of material, and water bodies deeper than 2 meters. So anything, even rock, even urban areas and others examples that you can think that express this first 2 meters below the contact with the atmosphere can be classified or at least should or can be used can use the WRB to classify. Now we have the fourth edition of WRB. That's a very good definition of soils and a very good example of system that could be applied to soil description and also soil classification. So, first, to start to understand better the WRB, we need to understand the master horizons and layers. So, again, we have the difference of horizons and layers, the same definition that we have in soil taxonomy. So, horizons are sections of soil formed by pedogenesis by soil formation process, and layers are those soil sections that are produced by other process. Okay, and now we have in WRB the O and H horizons slash layers. So they can be horizons or they can be layers. And the O and H, they are organic sections of soil. So the organic carbon content, it's quite high, and all the morphological, physical, and chemical soil properties in these sections are controlled by the organic matter, controlled by the content and the type of organic matter. We also have the A horizon, and the A horizon, as in the soil taxonomy, it's a mineral section of the soil with a dark color. So as you can see here, the A horizon express properties related to minerals in this specific section, but we have a strong influence of a partial decomposition of soil organic matter. We also have the E horizon. The E horizon also is a mineral section of the soil, and the E horizon express the eluviation, the expulsion of material, the losing of especially clay, something that gets the horizons a dark, a red, a yellow, or even green, or any other kind of color that you can think. But in this specific section, we don't have a lot of clay. Sometimes we have a very, very low content of clay. And because of this, the E horizon has physical and chemical properties straight related to silt and sand fractions. That's quite uncommon when we think in the other sections of the soil. We also have the B horizon, and the B horizon it's formed by strong soil formation process that induce accumulation of clay, accumulation of any kind of organic or mineral material that can migrate from the surface to the subsurface horizon. This B horizon also can concentrate minerals that are formed by weathering. They can concentrate calcium carbonate. It could concentrate salts. It could be cemented. We have a lot of different processes that express the formation of P horizon. We also have the C genetic horizon and the C horizon or layer. Okay, the C horizon or layer express a weak obliteration of the parent material and slash or a weak development of soil structure. So it's quite common to see in the sea horizon or the sea layer that we have a strong influence of the parent material. But now this parent material, it's a little, at least a little weathered. So, for example, I can see in the sea horizon some gravels of gneiss or basalt, and I can still see some stratification of, for example, alluvial sediments. So I can easily identify the parent material. But now I see that, for example, these rocks are not hardly broken. They can be easily broken because now a little of weathering destroyed the fresh rock and formed saprolite. Or I can see some of these alluvial layers or colluvial layers, but some of them, in some parts at least, I can see a weak formation of beds. And then I can express the sea horizon. I can call it as a sea horizon. The difference between the sea horizon and the sea layer depends basically on pad formation. If I can see at least a weak formation of pads, I can call it as a sea horizon. But if I only can see a weathered rock, a weathered parent material with no structure, with no aggregates, so I will call it as a sea layer. The W and the I layers, they are quite interesting in WRB because they have a correspondence with soil taxonomy. The W layer, it's a water layer. It's a layer or a section of soil composed basically by water. it it coincides with the water table in some cases. And the I layer is the ice layer. The I layer express frozen water. You can remember that in the soil taxonomy, the W and the I layers, they are only called W. So here in WRB, we have two specific horizons to express the presence of water, solid and liquid. Is basically the same case for the O and H because in WRB we only have the O horizon, sorry, and because of this O horizon, even in different conditions, can or we should call it as an O. And in the end, we have the R layer that express the fresh rock. So we have some similarities with WRB and soil taxonomy. I will try to highlight all the differences and similarities between them. And as I said, the first one, it's the first difference between the soil taxonomy and WRB is that in the WRB case, we have the O horizon only related to well drained sites, sites that it's not saturated by water and no drained by humans. So the O horizon express a very dark color and properties that are related to a high content of soil organic carbon. For example, very low bulk density, cracks that could express the shrinking and swelling of soil organic matter according to the water content. And this O horizon is basically formed in cold regions, in high mountains, or in areas that the chemical composition of soil could accumulate, could concentrate a high organic matter content. In general, in the majority of the cases, the cold environment or very low temperatures are the main cause to create, to form an O horizon or O layer. Okay. They express, as I said, high concentration of organic matter. This organic matter, it's non-limiting, so it's not formed by materials that were accumulated in fluid conditions. They are basically related to one specific process that's delivering. The littering, it's the concentration of soil organic matter in well-drained condition. The O horizon can express different stages of decomposition. So this organic matter can be poorly decomposed or highly humidified. And we can see the O horizon and the O layer at the surface where it is created, where it is formed, but also we can see it buried in some specific cases because an intense morphogenesis, an intense soil erosion in some specific parts, especially in lowlands, the O horizon can be buried, can be found buried. Okay. And we also have the age horizon or the age layer. Those horizons formed by a high content of organic matter, but in this case, related to the process that we call paludization. Paludization is one process that expresses a high content of organic matter related to accumulation in fluid conditions. As you can see in this picture, a high percentage of water can create or can induce accumulation of soil organic matter in also different stages of decomposition. And in this specific case, the age horizon sometimes can be drained, sometimes can express human actions. Okay. And it is also can be found at the surface or also buried by intense erosion. The A horizon express a partial decomposition of organic matter, and because of this, the melanization of a mineral horizon. So at the surface, we have a content of organic matter that it's okay, it's medium or can be high, but still low or at least lower than the organic carbon minimum value to identify an organic horizon. And because of this, the bulk density is high or at least higher than the organic layers and the organic horizons. And in this A horizon, all the soil properties are related to which kind of minerals can we found in the soils. But as I said, these properties also are strongly influenced by the partial decomposition of organic matter. Okay. The A horizon also can express just a little or no rock structure. So I cannot see in the A horizon an expression of the parent material, especially of the rocks. So all the biological activity should destroy the initial structure, the initial influence of the parent material. We also can identify in the A horizon an intense anthropic action, an intense anthropic influence. So some properties of the A horizon are created or induced or at least deeply influenced by humans. We also express in the A horizon some superficial process. So, for example, the destruction of clays or the erosion of clays that are light particles that can be easily removed or carried by the runoff. This also is one of the process that create A horizons. And the horizon also can be found in the surface or subsurface horizons. So in this second picture on the left, you can see a lot of white dots in this image, and these white dots are shells. And this dark color express a high organic matter content, but in this case, the organic matter content it's below the minimum value that we consider to identify an organic layer or an organic horizon in WRB. So because of this dark layer, this dark section steals a mineral horizon. Because of the color, we call it as an A horizon. And we also call it as an A horizon because all this morphological and the physical and chemical soil properties are straight related to human influence, to human action. So we have here both cases of A horizon. On the right, A horizon close to 100, 150 centimeters, a dark horizon at the surface that has dark colors because the partial decomposition of soil organic matter. On the left, we have a horizon thicker than 150 centimeters and with a lot of shells that express a deep human action. And because of this, we also called all this section as an A horizon. We have the E horizons, and the E horizons in WRB are quite similar to E horizons in soil taxonomy. The E horizons are those that express, as I said, alluviation or exportation or losing of any kind of material that can create soil color. For example, soil organic matter, minerals, clays, iron, aluminum, or the combination of these particles. So, because of the destruction or the elevation of these particles, we create a section of soil with a light or white color, and in some cases, a sandy texture that express this high content of sand and or silt and properties that are straight related to these coarse particles, sand and silt. Okay, we also cannot find a deep or strong influence of rock and parent material in the E horizons. Okay, now we have the B horizon, and as I said, the B horizon is a subsurface genetic horizon that is formed by several processes, and one of them is the eluviation. So the concentration of clay that migrates from the surface to subsurface horizon. It's one process that can create B horizons. And we also can express the B horizons for the concentration of clays or even soil organic matter. So in this case, we have this dark section below a E horizon. So here, this dark section also is a B horizon, expressing the concentration of organic matter that migrates from the surface to subsurface horizon. You can ask me again, JJ, how can I know that this dark section is not a buried A horizon? And again, I will tell you, we have a lot of morphological, physical, and chemical soil properties that are different between the A and the B horizon. Just to mention, for example, we have a very, very characteristic signature of soil organic matter in the A horizon and B horizon. So it's quite common that we can use the proportion of some components in soil organic matter that can be useful to identify a buried A horizon and a B horizon. But of course, we can use also morphological features. For example, the presence of some specific of type of structure, the presence of roots that are not connected to the E horizon or not connected to the A horizon or not connected to the surface of plants with are living on the surface. This also can be a feature or an evidence that express that this is a B horizon or an A, a buried A horizon. So we can use a lot of features and evidences to distinguish a buried A horizon and a B horizon. And we can talk about this later if you are interested. Just let me know, okay? But we cannot spend a lot of time describing these differences now. But believe me, it's quite easy when you know what you need to pay attention. The B horizons also can be formed by the residual concentration of some types of clays and clay minerals. So, for example, the presence of the abundance of kaolinite, iron oxides, manganese oxides, aluminium oxides, all of them are minerals that express deep weathering, and they are formed by this deep weathering. So the concentration of these minerals express the pedogenesis also, because express the leaching of silica, of silicium, and the concentration of iron, aluminum, iron, manganese, and other elements and minerals that are strongly influenced by weathering, but at the same time, they are highly resistant against weathering. The cementation of a section of the soil, a section of soil, because we have a lot of salts or calcium carbonate or a lot of iron. This also can express the formation of a B horizon, but also the removal or the losing of calcium carbonate or salts or gypsum or anything also can express the formation of a B horizon. The pedalization, the formation of aggregates or pads in a specific section of the soil also can express the B horizon formation, especially when this pedalization is also followed by specific colors that are different from the C horizon, are different from the saprolith, are different from the parent material. Okay, we also can identify the B horizon because we now see clay skins, pressure faces, friction faces. So we can see some specific shiny faces at the surface of pads or aggregates that express clay migration or shrinking and swelling of the material or any other kind of clay movement in the soil that could induce formation and or orientation of clay at the surface and then this shiny faces. The B horizon also express redoxymorphic features. So in the WRB system, we can use the presence of gray colors, models, plintite, petroplintite, and others as an expression of a B formation. Okay. And as I said, the B horizon is a subsurface horizon. So it is formed at the subsurface. So this is really important because sometimes you can identify the B horizon at the surface. And because of this, this express erosion of a surface horizon. Okay, so this is quite important, the erosion of a horizon, sorry. So this is quite important to understand. If you identify the B horizon at the surface, this means that the A horizon and maybe the A and E horizons, they were eroded in the past. The C horizon, as I said, express weak obliteration of the parent material, a weak pedalization, or even in some cases, no pads, no aggregates. So they are not present in that specific section. The sea horizon, it's not cemented. Okay, this is quite important. As I said, cementation is a process that creates the horizons. And to identify this horizon, we need to understand that there's a lack of properties related to the O, H, A, E, and B horizons. So I cannot see any kind of properties that express the formation of other horizons. So here you can easily see the same pictures I used in the past, a weak obliteration of parent material. I can see very easily in this section between below 60 centimeters that we have a strong influence of parent material in the morphology of of the material. But believe me, if you use a hammer here or even a knife, you can easily broke these materials because there's no fresh rock, only saprolite. So in this case, I have here a C layer. Here again, a C layer. If I use a hammer, I can easily break this section. The W layer now is that section that it's formed in the subsurface or at the surface and express a water layer, liquid water. Okay, as I said, a lot of times I can say several times I can see the water table or sometimes the perched water table in the soil profile, and then we classify that section as W layer. And we also have the I layer, solid water. So in this case, below 55 centimeter, you can see here this blue color, and this blue color is related to ice, to solid water that frozen because of very low temperatures. And then I describe this section as I layer. And in the end, we have the R layer. The R layer express the fresh rock or any kind of material that in this case is cemented, but not a cementation because any soil formation process. In this case, the R layer express cementation because we have lithogenesis and diagenesis. So process, I'm sorry, not soil process, but process related to formation of rocks. Okay. And the R layer cannot be easily excavated or cannot be easily broken by light materials. I should use heavy power equipments to break the R layer. I cannot, for example, I cannot break the R layer with my shovel. My shovel, I need to use something much more powerful and stronger to break the R layer. Okay.